There is a silence in the night sky that has bothered me for as long as I can remember. You look up, you see thousands of stars, and your intuition, that gut feeling that helps you navigate traffic or catch a ball, tells you that somewhere out there, someone must be looking back. It feels impossible that we are alone. But here's the problem with feelings. They evolved to help you survive on the African savanna, not to understand the structure of the cosmos. When you take that human intuition and apply it to the scale of the universe, it doesn't just fail, it snaps, it gets crushed. Because the moment you actually look at the math, the moment you look at the raw physics of how time, energy, and distance actually work, you are forced to confront a terrifying question. Why do we think our gut feeling has any authority over the laws of nature? See, on Earth, if you want to go somewhere, you go. If you want to go faster, you push harder. But out there, the rules change. The universe has set up 5 specific, merciless verdicts, 5 absolute walls that prevent civilizations from ever meeting. And I'm going to be honest with you, these aren't just hurdles. They are dead ends. By the time we finish today, you might feel smaller than you ever have before, but you will also understand exactly why no one has come to save us and why no one ever will. Let's strip away the science fiction. Let's strip away the Hollywood dreams. Let's look at the universe as it really is. The first verdict, and the one that breaks our brains before we even leave the ground, is distance. We say the word space casually, but we don't truly grasp what it means. We are biologically incapable of understanding the numbers we are about to discuss. Your brain is wired to understand distances you can walk or drive. Maybe if you travel a lot, you can conceptualize the distance of a flight from London to Sydney. That's your limit. So let's try to break that limit. Let's climb the ladder of scale. Start with Earth. It's a rock 12,742 kilometers wide. To you, that's a world. To the universe, that's dust. You can fly around it in less than 2 days. It's manageable. Now step back. The sun is 150 million kilometers away. Light, the fastest messenger in existence, takes over 8 minutes to cross that gap. If the sun vanished right now, you'd still be enjoying a sunny afternoon for 8 more minutes before the lights went out. That is a gap you can still sort of measure in time. But now take the next step, the nearest star. Not a distant galaxy, just the neighbor next door, Proxima Centauri. It is 424 light years away. Now, your intuition hears 424 and thinks, that's a small number. I can do 4 of something. But let's translate that into human terms. The fastest object humanity has ever built is the Parker Solar Probe. It screams through space at roughly 692,000 kilometers per hour. That is fast enough to get from New York to Tokyo in under a minute. It is unimaginably fast. If you hopped on that probe and headed for Proxima Centauri, how long would the trip take? A month? A year? No. It would take 6,600 years. That is the nearest star. If you had left Earth at the exact moment the Great Pyramids were being finished, traveling at the fastest speed humanity has ever achieved, you would just now be arriving. And that is the next door neighbor. Let's scale it up again. The Milky Way galaxy, our home city, it is 100,000 light years across. If you wanted to cross it at the speed of the Parker Solar Probe, it would take you hundreds of millions of years. That is longer than the entire evolutionary history of mammals. You would evolve into a different species before you reached the halfway point. And before we spiral too deep into the existential void, I want to ask you a small favor. We are about to tackle concepts that get much heavier, like why time travel is impossible and why your biology hates space. If you want to keep exploring the darkest corners of physics with me, just take a second to hit that like button. It tells the algorithm that you value truth over comforting lies, and it helps me keep making these deep dives. Okay, we have established that space is big, but you might be thinking, so what? We just need to go faster. And this brings us to the second verdict, the cruelest verdict, the speed of light. Most people think of the speed of light, roughly 300,000 kilometers per second, as a technical challenge, like the sound barrier. We used to think we couldn't fly faster than sound, and then we built a better engine, and boom, we did it. So surely we just need a better engine to break the light barrier, right? Wrong. The speed of light is not an engineering limit. It is a structural limit of reality. It is the speed of causality. It is the maximum speed at which an event here can affect an event there. Here is the trap. In our daily lives, if you push a car, it accelerates. If you push it twice as hard, it accelerates twice as much. This is linear thinking. But as you approach the speed of light, physics stops being linear. It becomes asymptotic. As you push an object faster, it gains kinetic energy. But as you get near that cosmic speed limit, a strange thing happens. The energy you pump into the ship stops making it go faster and starts making it effectively heavier in terms of relativistic mass. The more you push, the more the universe pushes back. To get a spaceship with mass to reach 100% of the speed of light requires not just a lot of energy, it requires infinite energy. I don't mean all the energy in the sun. I mean literally infinite. There is not enough energy in the entire observable universe to accelerate a single grain of sand to the speed of light. It is a vertical wall. You can get to 90%, maybe 99%, maybe 99.9999% if you burn a galaxy worth of fuel, but you will never, ever cross it. So when people ask, why don't aliens just come here faster? The answer is simple, because they can't. It doesn't matter if they are a Type 3 civilization that eats black holes for breakfast. They still live in the same universe we do. They still obey Einstein. And this leads to the practical nightmare of interstellar travel. Let's say you accept the speed limit. You decide, okay, we will just go at 10% of the speed of light. That's slow for the universe, but incredibly fast for us. This brings us to the third verdict, energy and the tyranny of the rocket equation. This is the one that really kills the dream. It's not about philosophy, it's about the gas tank. In 1903, Konstantin Tsiolkovsky wrote down the rocket equation. It sounds boring, but it is the most brutal equation in history. It says this: to move a ship, you need fuel, but fuel has mass. So to move the fuel that moves the ship, you need more fuel. But that extra fuel also has mass, so you need even more fuel to move the extra fuel that you need to move the original fuel. It is an exponential curse. Let's try a concrete example. Imagine you want to send a ship to the nearest star, and you want to do it in a human lifetime, so let's say 40 years. You need to accelerate to a decent percentage of light speed. And then, and this is the part everyone forgets, you have to stop. You have to decelerate when you get there. That means you need to carry all the fuel for the braking maneuver all the way across the galaxy, accelerating it the whole time. If you do the math using our current best chemical rockets, the amount of fuel you would need to accelerate a single human to Proxima Centauri in a reasonable time frame would exceed the mass of the entire observable universe. Okay, let's upgrade. Let's use nuclear fusion. We don't have it yet, but let's pretend. Even with fusion, to get a small ship to a nearby star, the ship would have to be almost entirely fuel. We are talking about a flying fuel tank the size of the Empire State Building to deliver a payload the size of a toaster. And what about antimatter? That's the holy grail, right? Antimatter is the most potent fuel source in existence. 1 gram could level a city, but here's the catch. We make antimatter in particle accelerators, atom by atom. It costs billions of dollars to make a few nanograms. To make enough to power a starship, you would need to dedicate the entire energy output of the human race for millions of years just to fill the tank once. And remember, the universe operates on a cost-benefit analysis. Even if a civilization is advanced enough to harvest the energy of a star, a Dyson sphere-level civilization, they are also advanced enough to do math. They would look at the energy cost of sending a meat sack or a robot to a tiny blue planet 10,000 light years away, and they would realize it is a complete waste of resources. Why burn a star's worth of energy to visit a planet that might not even be interesting, when you could use that energy to build a virtual paradise in your own backyard? Advanced civilizations aren't just powerful, they are efficient. And interstellar travel is the definition of inefficiency. But let's say they are stubborn. Let's say they have infinite money and they don't care about the laws of efficiency. They launch the ship. Now they face the fourth verdict, biology. We love to imagine humans in spacesuits hopping around looking cool, but the human body is a drama queen. It was evolved for one specific environment, Earth. 1G gravity, atmospheric pressure, magnetic shielding. Space is a radioactive hellscape. The moment you leave Earth's magnetic field, you are being pelted by cosmic rays. These aren't just light, they are high-speed subatomic bullets, protons and heavy ions moving near the speed of light. They don't just hit your skin. They tear through your hull, through your body, and smash your DNA to pieces like a shotgun blast to a library. On a trip to Mars, your cancer risk skyrockets. On a trip to another star, you are dead before you pass Pluto. You would need shielding meters thick, lead, water, concrete. But remember the rocket equation? Shielding is heavy. Heavy means more fuel. More fuel means more mass. It's the loop of doom again. And it's not just radiation, it's gravity. In 0G, your bones dissolve. Your heart shrinks because it gets lazy. Your eyes deform. After 6 months on the ISS, astronauts come back broken. Imagine a journey of 600 years. Oh, just put them in cryosleep, you say. Well, freezing a living cell causes the water inside it to crystallize, acting like little daggers that shred the cell membrane. We don't know how to freeze a person without turning them into mush. Generation ships, you say. Let them live and die on the ship, and their great-great-grandchildren will arrive. Have you met humans? Put 500 people in a metal tin can for 500 years. Social structures will collapse. Language will drift. Genetic defects from inbreeding will spiral. By the time they arrive, they won't remember why they left, and they certainly won't be in any shape to negotiate a treaty. Biology is the software of Earth. It does not run on the hardware of space. But maybe the aliens aren't biological. Maybe they are AI, robots. Silicon doesn't get cancer, right? True. But silicon is sensitive to radiation, too. High-energy particles flip bits in computers, corrupting data. Over thousands of years in deep space, without a genius bar to fix the hardware, entropy takes over. Circuits degrade. Metal fatigues. Micrometeoroids the size of dust grains hit the ship with the force of hand grenades because of the relative velocity. Even a machine has a lifespan, and the galaxy is wider than any warranty. Now we come to the fifth and final verdict, the one that truly explains the silence: information and time. Let's assume a civilization overcomes distance, energy, and biology. They are out there. Why haven't they called? Because the universe is a terrible telephone service. We have been broadcasting radio for about 100 years. That means our presence has formed a bubble around Earth that is 100 light years wide. In the context of the Milky Way, which is 100,000 light years wide, our bubble is a microscopic dot. We are shouting into a hurricane. For someone to hear us, they have to be looking exactly at us at the exact right time on the exact right frequency. Think about the Cosmic Haystack. There are billions of stars, billions of frequencies. If an alien points their radio telescope at Earth, but they do it in the year 1500 AD, they hear silence. We hadn't invented radio yet. If they listen today, but they are 200 light years away, they hear silence because our signals haven't reached them yet. This leads to the problem of asynchronous civilizations. Civilizations rise and fall. Humanity has been technological for maybe 200 years. We might last another 1,000, maybe 10,000 if we are lucky. But the universe is 13.8 billion years old. The chances of two civilizations existing at the same time, in the same neighborhood, at the same technological level, are effectively zero. It is like two fireflies blinking once in the middle of a dark forest, but one blinks on Tuesday and the other blinks on Friday. They never see each other. Someone might have lived on a planet near Proxima Centauri 1 billion years ago. They are gone now. Someone might rise there 1 billion years from now. We will be gone. The tragedy of the universe isn't that it's empty. It's that the party guests are arriving at different times. So when you combine these 5 verdicts, distance that breaks the mind, a speed limit that breaks physics, energy costs that break the bank, biology that breaks the body, and time that breaks the connection, the conclusion is stark. Aliens aren't coming, and this brings us to the elephant in the room. But what about the UFOs? What about the Navy videos? Look, I love a good mystery, but let's apply the physics we just learned. We see videos of craft accelerating from 0 to Mach 20 in a second. Do you know what happens to matter when you do that? G-force. To accelerate that fast would generate thousands of Gs of force. At that level, electronics flatten, metal liquefies, biological pilots turn into a red mist instantly. And yet these craft don't interact with the air. No sonic boom, no ionization trail. An object moving that fast in the atmosphere would rip the air molecules apart, creating a massive trail of plasma that would light up the sky like a second sun. You don't see that in the videos. You see a blurry gray blob. What is more likely? That an alien civilization mastered infinite energy, broke the laws of inertia, canceled out sonic booms, traveled 10,000 light years, and then decided to play hide and seek with a US Navy jet while getting caught on a grainy infrared camera? Or is it more likely that it's a camera artifact, a rotating gimbal glare, a drone, a bird seen through a parallax effect? I know it's boring. I know we want to believe, but extraordinary claims require extraordinary evidence, and blurry videos are not evidence. They are just blurry videos. If aliens were here with the energy output required to get here, you wouldn't need a grainy video to prove it. You would know. The physics of their arrival would be undeniable. But I promised you at the start that this wouldn't be a sad ending, and I mean it. Because when you strip away the fantasy of aliens coming to save us or destroy us, you are left with something far more profound. We are forced to look at the universe as it actually is, a place of rules, a place of structure. Think about it. If the speed of light wasn't a limit, causality would break. Effects could happen before causes. The universe would be a chaotic mess where history couldn't exist. The same rules that trap us here are the rules that allow stars to burn steadily, atoms to hold together, and life to evolve. The silence of the universe forces us to grow up. It forces us to realize that no one is coming to help us fix our climate or our wars or our economy. We are the only ones here. This fragile blue marble is the only lifeboat we have. And there is a beauty in that isolation. It makes us precious. If the universe was teeming with Star Trek ships zipping around, Earth would just be a truck stop. But in a universe of silence, Earth is a miracle. Life is a statistical impossibility that happened anyway. We are the universe waking up and looking at itself. And we aren't stopping the search. We are just getting smarter about it. We are looking for technosignatures. We are looking for the heat waste of Dyson spheres. We are looking for laser pulses. We are listening to the stars, not with the desperation of a child lost in a mall, but with the patience of a scientist. We may never shake hands with an alien. We may never share a drink in a cantina. But we share the same physics. We share the same elements. The carbon in your right hand and the carbon in an alien's left tentacle were forged in the same kind of dying stars. We are connected not by spaceships, but by the fundamental laws of nature. So the next time you look up at the night sky and feel that crushing silence, don't feel lonely. Feel proud. We are here. We are understanding it. We are the seemingly impossible result of 13.8 billion years of cosmic lottery. And for now, that is enough. We have to accept the verdicts, distance, time, energy. But we don't have to accept ignorance. Keep looking up. Keep asking the hard questions. And remember, the universe doesn't owe us an answer, which makes finding one all the more sweet. If you made it this far, you are part of the 1% who actually cares about the deep truth. If you want to join me on the next adventure where we tear apart reality to see how it works, make sure you are subscribed. Let's keep exploring the silence together. See you in the next one.